Hello and welcome to the Creation Kit scripting series Papyrus tutorials. This is the sixth part of the events and functions section, and it also marks a little subsection because we are going to start talking about function recursion. It's really important that you know what while loops are and have a decent understanding of how they work. I covered them in brief in the last episode. I highly recommend you watch the fifth part if you don't know anything about while loops. If not, let's get started. So what is recursion? We're performing the same function over and over, essentially. Typically, you have this large problem that requires you to loop over something, and you're breaking it up into smaller but similar chunks, if that makes sense. So let's look at an example that I did for the More Khajiits mod. Where there's a Khajiit priest in Solitude, and whenever you try to talk to him, he'll heal you if you are hurt. So we have function heal time, they equip the spell, they cast heal other onto the player, and then we get the health percentage of the player, and if the percentage is less than 1, it casts the function over again. At the very end, it will unequip the spell, and the function will be over. Okay. So, while loops. Nope, recursion is not like a while loop, unfortunately. Unlike while loops, recursion can occur indefinitely if you don't have anything that will limit how many calls that the function can do. If recursion happens indefinitely, it'll keep going on over and over and over. 1,000 calls or more later, it will cause your game to crash because I wrote here memory leaking, but basically all of the available memory on your computer for Skyrim has been taken up and it can't do anything else. So, why would somebody use recursion? Recursive calls are handled more efficiently than while loops typically. They can be easier to keep track of the steps for the debugging process. And you can use a bunch of different functions in the recursive process that leads to cleaner functions overall, and you can be more specific on the purpose of the said function. Let's see, are recursive functions different from normal functions? Well, recursive functions can have parameters, and they can also have return values, so that's all like normal functions there. The only difference is recursive functions are calling themselves. So, let's look at a few mathematical examples that aren't Papyrus related yet. We will code these up in the live coding section, but it's a good idea just to step through the steps. So, a factorial is a number and then you usually see an exclamation after it if you've seen it written in math before. If not, a factorial is you have your number like 4 exclamation, and it's 4 times 3 times 2 times 1, and in most programming it's also times the 0th case, which is times 1 again. It doesn't matter because 1 times 1 is 1. Anything times 1 is itself. So this is a function that returns an integer factorial, and then you have an integer for the input. If the value is 0 or n, as we have here, it returns 1. In all other cases, it's going to return your number multiplied by the factorial below it. So let's look at 4 factorial again. So we get to this else case, and it's going to be 4 times the factorial of 3. And then the factorial of 3 is going to split up into 3 times the factorial of 2. Then the factorial of 2 is going to split up into 2 times the factorial of 1. And then factorial of 1 is going to split up into 1 times the factorial of 0. Then factorial of 0 is just going to be 0, or not 0, 1. So it's going to be 4 times 3 times 2 times 1 times 1. Let's look at another math example that's another common one that they use when teaching recursion. So, Fibonacci. It's a recursive sequence, as they call it. And for values 2 and greater, Fibonacci sequence, it's previous value plus the previous value of the previous value. So, whenever your input value is 0, the value is going to be 0. If your input value is 1, it's going to return 1. And then for every other case, it's going to be the Fibonacci of n minus 2 for the previous of the previous, and then you add that to the Fibonacci of the previous, n minus 1. And then if there's anything else outside of that, we'll do an error. You don't need this else necessarily. The n equals 0 up here, you could change that to be if n is less than 1, because it'll cover all cases below 1. But anyway, let's think about the Fibonacci of 2 real quick. So the Fibonacci of 2 is going to be the Fibonacci of 1 plus the Fibonacci of 0. So the Fibonacci of 0 is 0, so it's going to be 0, and then plus the Fibonacci of 1 is 1, so it's going to be 0 plus 1, which will return 1 for the Fibonacci of 2. Looking at the Fibonacci of 3 real quick, it's going to be the Fibonacci of 2 plus the Fibonacci of 1. The Fibonacci of 2 is going to split again, and it's going to be the Fibonacci of 1 plus the Fibonacci of 0, and then we add on to the other call, Fibonacci of 1. So there's 2 Fibonacci of 1s, essentially, and the result's going to be 2, because 0 plus 1 plus 1. Alright. Now let's actually play around with a few recursive functions. So, we are going away from our traditional cell that we've been using with the health skeever, and we just have a simple logic barrel. Let's look in. Ow. Okay. Because I recorded this video and there were some problems, I'm just going to have to redo this function. That's okay. Let's go to the source. Delete that. And let's give ourselves a recursion tutorial script. Creation kit's confused out of its mind. So, let's give it a new name. Okay. Let's go here. Let's go to the actor, player. Okay. Let's go to the source here. Open this up with Notepad++. Here we go. And let's give a comment to our player property. And we're going to use an on a note only in this episode. So retrieve the player. So it's going to be player is equal to game.get player. Okay. And now then the first recursion call factorial, second recursion call Fibonacci, and third recursion call die player die. We are going to kill off the player in the third recursion call. So we want to use debug message boxes here, and we're just going to do the factorial of 4. And it should be 24 once this is all said and done. And we're going to input 4. Let's do our message box for Fibonacci. And this one should be 2. And then we're going to call die player die. So let's start off with our first recursive function, factorial. So our input is going to be the base value or subsequent values, because this is a recursive function. The purpose of this function is to recreate the mathematical formula for factorial. And then let's give it an example just so. It's going to equal 4 times 3 times 2 times 1 times 1. Something that might be helpful also, just because we're doing recursive functions, this is not something you have to do. So equal 0, return 1. Just so you can keep track of what it should do. So let's create our factorial and give it an int num for the input. Oh, let's also give it a function, and int function our base case num equals 0. So if num is equal to 0, let's create our else block there. We just want to return 1. Then else, we want to return the following. So it's going to be our number times our factorial of number minus 1. The spaces are important here. I had a bug whenever I was doing some recording before, where if you have number minus 1 together, the compiler yells at you. I don't know why. It's just how Papyrus compiler cannot handle it. So every other case, perform the number times factorial of previous number. That should be our recursive factorial function. Let's go through here. And start creating our Fibonacci function. Input base value or subsequent values. Purpose of this function is to recreate the mathematical sequence of Fibonacci. Let's give it an example. Fib of 2 is equal to fib of 1 plus fib of 0, which equals 1. Then let's give it a second example. Fib of 3 is equal to the fib of 2 plus the fib of 1, and that's going to equal fib of 1 plus fib of 0 plus fib of 1, which that's going to equal 2. And let's just to keep consistent with what I did above, let's give it a base case. N equals 1, return 1. N equals 0, return 0. Okay. Again, this is going to be of type int, and let's create our Fibonacci. And then we're going to give it num again as the input. So first base case num is equal to 0. If the num is equal to 0, return 0. Second base case num is equal to 1. So num is equal to 1. Oh, let's change this up here to be less than 1. Just so we cover all cases. Return 1. And then this is all their cases. In all other cases, we're just going to add the values together. So return our Fibonacci of num minus 2 plus our Fibonacci of num minus 1. Okay. And then we want to end if. Oh. We forgot that up here. Okay. So we are going to now go on to our final recursive function. Input none. Purpose of this function is to slowly kill the player. There's no return value on this one, so we're just going to say function die player die. There's also no parameters in this example. So I made a mistake on this. Let's look. Here's my cheat sheet. Alright, so the steps we're going to do is check to see if the player's dead or not. Hurt the player, do a wait of some sort, and then call the function again. Instead of using my cheat sheet for actually coding this up, let's go and do this right on the Creation Kit wiki. Okay. So the functions we want are damage actor value, and we want to find is dead. Okay. So let's go back to here. Check to see if the player is still alive. If, and then we want to do the not of this. Player that is dead. Basically, that's going to say to check if he's alive or not. Damage the health. Player dot damage actor value. Then the argument is going to be health, and then the value that we want to damage it for. Let's do 45 in this case. Perform a wait before next call. Since we're doing it recursively instead of using an update game time, that would have been somewhat iterative, not recursive, excuse me. But we're doing recursion in this episode, so 15 seconds not good, so let's try 4 seconds, then call the function again. And I think that should be it there. Let's go to the creation kit. Editor source. Save it. It's compiled successfully. I will see everybody in game after I save here to test everything out. Alright, we are in game. Once it finishes loading, we should see the message boxes, and then the player will be hurt after the message box. So, that is correct. We got 24 for the factorial value. So factorial is working. Notice it's already applied the first recursive function down there. And our Fibonacci is too, so Fibonacci is working. Let's see. Slowly the player is going to die here. If you notice, the health is just dropping. It's going to be ever so slow. The base case in the case of die player die is if the player's alive or not. It's a Boolean value instead of having an integer-based value. That's okay. And next call should do it. Yep, player's dead. I will see you in a moment back in the episode. And we are back. If you have any questions about the content in this episode, previous episodes, future content, any scripting questions in general, feel free to contact me at my Nexus forum profile or Nexus profile in general. Also, YouTube, I can respond to YouTube comments and such if you send me a message like, hey, how do I do this? So, hope you got the most out of this episode for Recursion. We are going to be spending the next few episodes going to more depth on Recursion, how to deal with base cases, things like that. We're also going to go over a myriad of examples mathematically, before we exit the Recursion section to move on to more within the events and functions segment. I will see everybody on the next episode.